Okay, so our last little tidbit of information would be our last three quadrilaterals. I know it only says two, but there's actually three. I snuck an extra one in there, talking about trapezoids and kites. Okay, so okay, that didn't work out so well. There we go. Okay, there's a trapezoid. So the question is, what is a trapezoid? Scott?
Quadrilateral.
Good start. It's a quadrilateral.
One pair of parallel lines.
One pair of parallel sides. Yes? Can it have two?
And then it'll be square. Well, no, that'll be a rectangle or square.
For parallelogram. Okay. Good. Any problems? Exactly one pair of parallel sides. Now, when you do this whole geometry thing, there's some different ways that you can approach this. So we could change the definition of a trapezoid and say that it has at least one pair of parallel sides. But that opens up a whole weird can of worms there, because then it might be a parallelogram or it might not be a parallelogram. By going with exactly one pair of parallel sides, it can't ever be a parallelogram. Can that trapezoid ever be a square? No. Can it ever be a rectangle? No. Can it ever be a parallelogram? No. Can it ever be a rhombus? No. Can't be anything but a trapezoid. And it's a very boring shape. There's only two things that we care about with a trapezoid. One, we already have, the parallel sides. What else is true about that figure? Brilliant.
I forgot how to say it, but like T and R are gonna have the same like angle, and T and A are gonna have the same angle.
Not in this shape. We'll get to that in a second. But you're on the right track. Anybody else? Those are parallel lines. What do you know about angles around a parallel line? I don't know why I'm ending every sentence by a higher note. It's starting to get irritating. Dan?
Angles T and P are going to equal angles R and A.
Maybe if you explain more carefully.
Because T and P, when we add them, they equal 180, and the same for R and A.
Okay, good. So there's a whole bunch of stuff to unpack there. So the first thing is T and P add up to 180, also known as,
Same side.
say again?
Same side interior.
Same side interior angles. Okay, so angle T and angle P are supplementary. Angle R and angle A are supplementary for the same reason, same side interior angles. Therefore, the sums would both be 180 and they'd be equals. Okay, good. That's it. Okay, as it says, oh, I forgot the terminology there. The parallel sides are called bases. The non-parallel sides are called legs. What's the matter?
I checked my calendar and it's left to go at 45.
Okay.
Should I go?
Your heart thing is at 45?
Yeah, just like 5 minutes early.
Then that would be 40.
Yeah, so like.
That leaves you 2 minutes to get down there.
Yeah.
Where'd you get the notification from?
I downloaded a calendar on this, so I have my stuff. Where'd you get it? It's gonna go. Oh, you did it?
I literally don't have anything to say. I don't know where to go with that. I hope his heart's okay. Let's go with that. Okay. Yes, Brody?
Does that mean like?
What did I miss?
Mine's a 250, which I wrote on my hand so I wouldn't forget.
Okay, good. I mean, you could have just set an alarm on your iPad or something, but your hand's not going anywhere, so you know. Okay, good. Sorry, buddy, what was that?
Does that mean like T and P are supplementary, but also T and A would be supplementary?
They are not.
Okay.
Yeah. There's no relationship. When you go across the trapezoid, there's no relationship.
So it's just
Only T and P are supplementary, only R and A are supplementary. Okay? Those two angles at the bottom are called base angles because they're attached to the same base. By the way, my diagram is wrong. They should not be marked congruent. That was my fault. I didn't realize it till just now. Okay, those are base angles. The other angles up on top attached to the same base are also base angles. I did that one correctly. By the way, what do we know about all four angles?
Yeah, 360.
Equal 360, good, because it is a quadrilateral stone. Okay, so we talked about, there's a fancy way of saying what Dayan said, consecutive non-base angles are supplementary. You want to think about that as same side interior angles, however whatever is going to help you put that together with the trapezoid, we're okay. There's nothing else exciting about a trapezoid. It's a boring figure. So how can we make it more interesting? Well, one of the problems, or one of the types of problems we're going to get into a lot is some coordinate geometry with quadrilaterals. Here are 4 points that make up a quadrilateral. What kind of quadrilateral is it? If you want to show that something is a trapezoid, you have to show that one pair of opposite sides are parallel, using slopes, but you also have to show that the other sides are not parallel. Because if the other sides are parallel, all of a sudden it gets into that parallelogram realm. Does that make sense? So the audience participation part of the program, does that make sense? Thanks, Liz, appreciate it, glad you're here. Okay, now let's make things more interesting. We'll take that trapezoid and we'll make the legs equal. Because you know what the word isosceles means, equal legs. Isosceles triangle, triangle with two equal sides. Isosceles trapezoid, two equal legs. Because an isosceles trapezoid is also a trapezoid, all the other things we talked about are true. Angle F and angle G are supplementary. Angle R and angle O are supplementary. FR is parallel to GO. Two major things change when it becomes isosceles. Any guesses? No?
Do the legs become perpendicular?
Nope. Nope. Dan?
The opposite angles equal when
Could you explain why? Hi, Julia.
Hi.
How are you?
I'm good, how are you?
Ready to quiz it up?
I am ready.
Do you mind, do you want to go out in the hallway or you want to sit in here?
Head of the hallway.
Out in the hallway, good. Scott, you gotta move. Okay. While I'm getting Julia set up, there are two things about that isosceles trapezoid that are not true about the regular plain old trapezoid. If you could figure that out, that would be great to save us some time. I will be back shortly. It is calculator.
It is?
Yeah, so if you want to drop your bag there inside the door, grab your calculator and a pencil, and then you can just put your phone on top of the, well, that'll work too, whatever. Thanks, Scott. How are you this morning? I was gonna ask you how did it go. Yeah, you felt it. I mean, you don't get results right away. 2 weeks? Oh, I guess they gotta have a cardiologist read it. They're not gonna let somebody read it. If you need need some color. All right, what do you got for me? Oh, I thought you were leaving too. You okay? I'll sit here with you. It's okay. The psychological scarring is it something Evan did? You can tell him he's okay. He's got thick skin. He said he bothers you. I get it. Scott.
Angles F and R equal.
Angles F and R are equal. Do angles F and R appear to be equal?
Yeah.
Yeah? So expand upon that.
They both
No. Expand upon another pair of angles.
F and G equal 180.
We knew that already because it's a trapezoid. So we got F and frog, raccoon are equal. Frog, gopher are supplementary. Raccoon, octopus are supplementary. And is good. Gopher, octopus are equal also. Okay, so in other words, the base angles are congruent. A trapezoid has a pair of congruent bases if and only if it's isosceles. We'll talk about the if and only if in a little bit. Anything else? I didn't think you'd get the other one, but if I drew in segment GR, gopher, raccoon, and segment frog, octopus, what can you tell me about the diagonals of a trapezoid? Go.
They're gonna be equal.
Good. Diagonals of a trapezoid cannot be perpendicular, but they are congruent. Sorry, isosceles trapezoid. Okay, plain old trapezoid diagonals are not congruent. In an isosceles trapezoid, they are congruent.
So that
FO and RG would be equal, yes.
I just thought F and R are equal.
The points or the angles?
On the angle.
Yeah, the angles are congruent.
If you mean by the points, then, oh, like the midpoint?
Yeah.
Oh.
No, points can't be equal. That's why I was confused. I thought you were talking about the point F being congruent to the point R, and that makes no sense. But the angle F is equal to the angle R.
Okay, so then with the diagonals, what are they equal to?
Each other. FO is congruent to RG.
R.
Okay. Good. One other thing about a trapezoid. It's called a mid-segment. And the mid-segment is a segment connecting the midpoints of the legs. So I got a picture for you there somewhere. Hold on. Come on. There you go. Okay. So R and M, raccoon, mongoose, are the midpoints of those legs. When you connect them, you get what's called a mid-segment. Okay, I'll come back to this example in a second. Let me go back to this slide. So there we go. Number one is the definition of a mid-segment. It's the segment connecting the midpoints of the legs. And number two, it's the average length of the bases. Rosemary, how do you find an average between two numbers? Don't look at me in that tone of voice.
You add it up and then divide it,
By?
however many you have.
You didn't hear my question, did you? Rosemary, how do you find the average of two numbers?
Yeah, divided by 2.
Okay. Rosemary, how do you find the average of 9 numbers?
Divided by 9.
What's it?
The number after you add it up.
Okay.
Yeah.
Tired today?
Very.
Simple solution for that. It's called sleep.
Thanks, Captain Obvious.
The best part is that's recorded, so we can play that over and over. I can send that home to your parents. Here's Rosemary geometry being sassy. Tired and sassy, a bad combination. Okay, so what? those Bears coming down Lincoln Park? It's exciting. At least my driveway for parking to make $1 billion. Come on, park here. Let's get those scooter ready. Let's see. Shops, All right, we good now? Okay, beautiful. Let's do some math. How long is TS? Turtle, salamander. You might need your calculators, by the way. Now notice, I skipped the easy stuff. I didn't give you hippopotamus, aardvark, and turtle salamander and asked you to find raccoon mongoose. I gave you one of the bases and one of the mid-segments and asked you to find the other base. By the way, before you do the calculation, Kushi, what can you tell me about the length of TS as it compares to the length of hippopotamus, aardvark, and raccoon mongoose?
The length of TS and HA together is the length of RM. Like the average of HA and TS is.
Correct. What answer, if I told you this, the length of TS is 17, how would you feel about that?
I don't think that would be correct.
Why?
Because the average is 38.5 and it would need to be over 20. I mean, the number would need to be over 38.5.
Okay, so you wouldn't like 17. Would you like -4?
No.
That's ridiculous, right? It's insulting to ask that question. Okay, beautiful. Does everybody know the length of TS? Brody?
51.
Say again, I'm sorry.
51.
5'1"? Anybody confirm?
Yeah.
Yes. Let's see what I got. I got 51 also. In a problem like this, when you're solving a problem like this, you want to set up an equation. So, for instance, let's suppose I set up the equation x. Okay, let's suppose I set up the equation x plus 26 divided by 2 is equal to 38.5. What's wrong with that equation? Scott?
Should it be TS?
It could be.
That was just after
So you would rather have TS plus 26 divided by 2 equals 38.5. That's perfect. What's wrong with my equation?
that. Cue into the doors.
How'd it go?
Oh, it was really scary.
I know. Did they zap you?
Yeah.
Cool.
How was that?
Follow.
That should be a
Was it
parentheses.
cool?
Parentheses 26.
Nope.
It was just sticking with like jello.
What else?
Was it cold?
The problem is this is so obvious that you might not understand my question. Where's X? Okay?
Yeah,
Right. How do you know that?
because you're adding the two bases together, and 26 is the first base, and TS is the other base.
You're also basing it on some knowledge that you already have. The problem with this is that I introduced a variable, but there's no variable over here. How do you solve the problem? Just put an X down there. Or, like Scott said, you could just do TS plus 26 divided by 2 equals 38.5. Question in the back.
I mean, my answer worked, but can't you just do 38.5 minus 26 to find like the repetitive like stages to find it? Like how it would keep on going if it
Ooh.
like kept going? Because that's what.
Everybody understand what he's saying?
No.
Explain.
So like 26, the distance from 20 or HA to RM is the same as it would be from RM to TS.
You're saying those two distances are the same?
Yeah.
Okay.
Because it's the midpoints of AMS and HRT, because if it's the midpoint and they're both congruent to each other, then that's the same.
So you found this distance?
And I just added it to 38.5.
That works. Yeah. solve the same problem. Okay, good. All right, kites. There's a kite. I turned mine sideways. It's called a kite because it looks like a kite. I don't know which came first. I don't know if the quadrilateral came first or the flyy things came first. This will be fun. We need a definition. What makes a kite a kite?
It flies.
That was my fault. I'll take a hit on that. We need a definition of a geometric kite. Scott?
The line from I and E will be.
Oh, I can't use I and E
From those two.
because we need it for every single kite, not just one that's labeled KITE.
Yeah, the line from those two angles, will be bisected by the line from the top and the bottom angles, but the
Is-
top and the bottom angles won't be bisected by,
You're not wrong, but is that a definition or is that a property?
well,
Property. We'll come back to you. Rosemary,
Well, I have a question.
what'd you bring us? You brought us treats?
No, that's not for you, that's for H1.
Yeah.
Sorry.
Oh, where's my
And that's the one.
I'll bring you some.
He's not gonna be here on Friday.
Oh, I'll bring you some tissues. Anyway, back to the thing.
Okay, you never did give me a donut.
Is it?
know.
Okay, I'll bring it on Friday. Anyway.
You bring everything. No, you didn't. Sonny didn't get a donut. See, I didn't get a donut. Yes, Rosemary, sorry. Definition of a kite, go.
Well, I don't know the definition, I have a question. Is a kite a rhombus?
Great question, let me ask the crowd. Is a kite a rhombus? Why not?
Because all
It's not equilateral.
It's not equilateral, also known as all four sides are not congruent.
I thought it was called a rhombus.
A what?
A rhombus.
I know, she mispronounced it, I didn't want to make her feel bad.
Oh.
Okay. So what do we got? What's a kite? Let's start easy. What kind of thing is it? It's a quadrilateral, I like that. However, is it a parallelogram?
No.
No.
No, not a parallelogram. Okay, so it is a quadrilateral with what?
Two sets of equal sides.
Two sides of equal sides. I love
Yeah.
that. Except, how is that different from a parallelogram? Because doesn't a parallelogram have two sides of equal sides? What makes a kite and a parallelogram a parallelogram? You're right there. So close. Somebody help them out. How do we distinguish between the parallelogram definition, which says it has two pairs of congruent sides, and a kite definition, which says it has two pairs of congruent sides? Is that what it is?
They intersect.
They do in a parallelogram too, but it's a good try. Cushy.
Because a parallelogram is a quadrilateral with opposite sides that are parallel to each other, and a kite does not have opposite sides that are parallel to each other.
You're not wrong, but it doesn't address the question I asked with the congruent side. Becca.
The sides that are equal are adjacent and not opposite each other.
I like that. Right? Where are the congruent sides in a parallelogram? Opposite each other. Where are they in a kite? Next to each other. Good. Fancy term for that is consecutive. Okay. Consecutive congruent sides, but opposite sides are not congruent. That little bit left at the end there, that but opposite sides are not congruent, is there to make sure that it's not a rhombus. So we've established that that's not a parallelogram, which means it can't be a rhombus, a rectangle, or a square. Can it be a trapezoid? Nope. So a kite is that weird shape all by itself. Whoops. Wait, let me see. All right, let's go back to this guy. Sorry, I'm a little click happy here. Let's get some terminology. So vertices K and T, those are the vertices between the congruent sides, are called ends.
Do we have a quiz on Friday?
No,
Lifesaver.
I'm here for you. Okay? Let's talk about some properties. The reason those are called ends is so that we can make a distinction between the diagonal that connects the ends and the diagonal that doesn't connect the ends. We don't want to use K and T and I and E because that applies for this particular kite. So let's start simple. What can you tell me about the relationship between the diagonals in that kite? Scott,
The thing that I said before,
give it to us again.
the endpoints intersect the other 2 points diagonal, but the other 2 points not doesn't bisect, but the other 2 points don't bisect the endpoints diagonal.
Beautiful. I'll summarize this on the next slide. The diagonal that connects the ends bisects the other diagonal. In other words, for those of you that are visually minded, that is congruent to that. Whoops, hold on. There you go. Those two are equal. The other two are not equal. Think about folding that kite in half. If I fold the kite, this is a visual look up here. If I fold the kite this way, it'll fold onto itself. If I fold it this way, it won't work. Big triangle over on the right, small triangle on the left, won't fold onto itself. What else about the diagonals? Bob? They are perpendicular. Very good. Okay, so let's click and see what we got here. Diagonals are perpendicular. Thank you. Exactly one pair of opposite angles are congruent. So if we go back to our picture, this angle is equal to this angle, but K and T are not congruent. The angles at the ends are not congruent. That's what Scott said. One diagonal is the perpendicular bisector of the other diagonal. Okay. I'll give you a second to get caught up.
Are you getting your EKG?
I what?
Are you getting your EKG?
I already got one.
I don't like the
Healthy as a horse. By the way, for those of you that can, I would highly suggest that you, if you haven't already done so, to become part of that EKG program. I've had numerous players in the past find out that they had some heart defects that were fixed because they found it on that EKG program. Scary.
Yeah.
I'm going to fly through these examples because I want to move on to other stuff, and the kite isn't that important, especially since you realize that that kite is made up of 4 right triangles. So you can imagine that there's going to be a lot of Pythagorean theorem. There's going to be a lot of trig going on there. Okay. So if RT is 24, that means that this is 12 and this is 12. Therefore, Pythagorean theorem to find ST, Pythagorean theorem to find AT. AT and RA match, SR and ST match. Okay, we'll skip the math here, and it'll be, the slideshow will be, or the video will be available. If you want to go back and solve the problems, you can, but there's some on the homework for you.
That was fancy.
I like how they balance and stuff.
I've been playing a little bit with the transitions in PowerPoint. Hope you appreciate it.
Oh yeah. Oh, I appreciate a ton of this.
Cool. Simple problem. What do you know about angle B, angle U, angle G, and angle S together?
360.
360. What do you know about angles? Unicorn? All right, fine. What do you know about angles unicorn and salamander?
What about sloth?
Well, they have to
Equal.
Very cool.
They're equal. No, That's in a trapezoid. Okay, so if I was solving the problem, I'd introduce a variable here. I'd say that's x, and then do 2x plus 62 plus buck 32 is equal to tree 60, because it's still a quadrilateral. Solve, blah, 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 answers. Problem is this takes forever.
It's okay, it looks cool.
It does look cool.
Yeah.
This guy.
There's, 83.
Perfect.
Did not see that.
I was trying to, like, what question could he possibly ask? And then,
Did I get it one?
oh yeah, he did. Yeah, good job. Yeah. Okay, good. Day 4. We're good. Question? Okay. So, let me stop this. Discard. Stop recording.